Hello everyone, welcome to another video in my channel. In this video, I will be solving this year's NECO Further Mathematics number 6 theory question. The question says, an object of mass 7 kg is suspended by two light inextensible strings XP and YP of lengths 60 cm and 80 cm respectively. The ends of the strings X and Y are attached at the same level to 2 points whose distance apart is 100 cm. Find the tensions in the strings. This is a diagram representing or illustrating the question above. You see, point P is the point where X and Y are connected to the object. And we are told that X and Y are 100 cm apart, while from point P to point Y is 80 cm, and then from point X to point P is 60 cm. Now T1 and T2 are the tensions in the springs, and that is what we are looking for. We are given a triangle, and the sides of the triangle are also indicated, but the internal angles of the triangle are not given. We first of all need to calculate the values of the internal angles of the triangle. And then after that, we will apply the triangle law of forces. Then after applying triangle law of forces, we'll be able to find T1 and T2 when we apply sine rule. So the first thing we're going to do is to apply the cosine rule, because we are given all the sides, but all the angles are not given. So cosine rule is proper for us to apply here. So I'm going to state xy squared is equal to xp squared plus py squared, then minus 2 times xp times x times py rather, then cos theta 1. Now, theta 1 is the angle opposite to xy, and xy is the subject here. So we are looking for the opposite angle. The opposite angle is theta 1. Now, putting the values of xy, xp, and py in this equation, we have 100 squared is equal to 60 squared plus 80 squared minus 2 times 60 times 80 cos theta 1. Let us remember, our purpose is to find the value of the internal angles. I can find any two of the angles, and then after that, I will apply the sum of angles in the triangle to find the third side. And let us proceed. 100 squared is 10,000. 60 squared is 3,600. 80 squared is 6,400. 2 times 60 is 120, and 120 times 80 is 9,600. Then we have cos theta 1. So let's add these two together. We have 10,000 again. When we add them together, then minus 9,600 cos theta 1 is equal to 10,000. When we subtract both sides by 10,000, we have 0 here is equal to minus 9600 cos theta 1. And so, when we also add this value to both sides, we have 9600 cos theta 1 is equal to 0. So, divide both sides by 9600, then 9600. This and this will cancel out, giving us 0, because 0 divided by this is still 0. So, cos theta 1 is equal to 0, and so theta 1 is the cos inverse of 0, which will give us 90. The cos inverse of 0 is 90. So I have theta 1 as 90 degrees. I'm going to look for theta 2. So theta 2 is opposite to xp. So xp squared is equal to xy squared plus yp squared, then minus 2 times xy times yp, then cos theta 2. Good. xp is 60, so I have 60 squared. Xy is 100 squared. Yp is 80 squared, then minus 2 times 100 times 80 cos theta 2. 60 squared is 3,600, and this is 10,000, and this is 6,400, then minus 2 times 100 is 200 times 80, we have 16,000, then cos theta 2. Let's add these two together. When we add together, we'll have 16400, then minus 16000 cos theta 2. That is 3,600. Let us subtract both sides by this term. So it becomes 3600 minus 16400 equals to minus 1600 cos theta 2. Proceeding, 3,600 minus 16,400 will give us 12,800 minus, please, is equal to minus 1600 cos theta 2. So let's divide both sides by this term. So we have cos theta 2 being equal to 12800 over 16000. When we divide, we get 0.8, and so theta 2 is equal to the cos inverse of 0.8, which will give us 36.87 when we punch our calculator. So we now have that theta 1 is 90 and theta 2 is 36.87. We can now find the third angle, which is theta 3, and we are going to do it using sum of angles in a triangle. That is 180 minus theta 1 plus theta 2. So theta 3 will now be 180 minus 90 plus 36.87. And we punch our calculator, we are going to get 53.13 as our theta 3. Having found the value of theta 1, theta 2, and theta 3 in this triangle, we can now properly apply triangle law of forces. The triangle law of forces states that if three forces are in equilibrium, they can be represented in magnitude and direction by the three sides of a triangle. So having that information, I am going to redraw these three forces. That is, this force 70 Newton. And by the way, how do we get this 70 Newton? We multiply the mass of the object by the acceleration due to gravity, which is the force per unit mass. The force per unit mass is given as 10 meters per second squared, as we can see it here. Now, I was saying that I am going to redraw these three forces to form a triangle, applying the triangle law of forces. I like to start with the vertical one. So if I start with the vertical force, which is the weight of the objects acting downwards, where it ends, I'm going to start T1 from there. And so T1 begins from where the 70 Newton force ends, and then we'll have to draw it. This is our T1. Again, T2 is the third force, and it will start from where T1 ends. So I will now draw another force closing the triangle, and so I have a triangle. Now, what I need to do is to find the value of T1 and T2. Let us remember that the angles we got for theta 1, theta 2, and theta 3 are these: 90, 36.87, and 53.13. So how do we put in the values of the angles in this triangle? First, if we put a perpendicular to this line xy, we are going to have that this angle is the complementary angle to this theta 3, and theta 3 is 53.13. So here becomes 36.87. So I'm going to put 36.87 here. Let us also do the same thing to this other side. If I put a perpendicular to this xy at point y, as I did at point x, I am going to get the complementary of theta 2. Let's remember theta 2 is 36.87, and so its complementary is 53.13, and so this angle is 53.13. We know that this is theta 1, and theta 1 is opposite to the largest force. How do we know that the largest force is the 70 Newton force? Because the sides, or the angle rather, opposite to it is the largest side. Now here becomes our 90 degrees, and so our triangle is complete. What I need to do now is to apply the sine rule. The sine rule has it that sine 90 all over 70, that is the sine of the angle to its opposite side, is equal to sine 36.87 all over theta t1 rather is equal to sine 53.13 all over t2. Now sine 90 is 1, so I have 1 over 70. Sine 36.87 is 0.6, I have 0.6 over t1, and sine 53.13 is 0.8 over t2. So equating this, and then after this and this, we have 1 over 70 is equal to 0.6 over t1. Cross multiplying, t1 will now be 70 times 0.6 will give me 42 Newton. Secondly, when we equate this to this, we have 1 over 70 equals to 0.8 over t2. Cross multiplying, t2 will now be equal to 70 times 0.8. And then 70 times 0.8 is 56 Newton. So T1 is 42 Newton and T2 is 56 Newton.